By now you're hopefully starting to get the hang of what global storage is all about, but perhaps thinking that the APIs to access and manipulate them are all a bit clunky. Although expressed in JavaScript, they don't particularly blend seamlessly into a JavaScript way of thinking about things. Well, if so, I'd agree with you, and I decided that there must be a better way. So let me take you through the thinking behind what I'm then going to explain in detail in this final section of the course. As this title slide suggests, I realized that it should be possible to abstract global storage as if you were dealing with persistent JavaScript objects. So let's start with this example global that we've been working with throughout the course. On the left, represented in the way it would be conceptualized in MUMPS technology terms, and on the right, that same global represented as a hierarchical tree. Now, if you're familiar with JSON, it should be immediately apparent that there's a direct one-to-one correspondence between this global on the left and a corresponding JavaScript object represented on the right as a JSON structure. Of course, I mentioned this much earlier in the course when I was describing how global storage could be used to model the different NoSQL database types, and here you see how global automatically models document database storage. The key to this mapping is to recognize that a global subscript can also be thought of as a JavaScript object's property. There's a direct one-to-one correspondence. So if we extrapolate this thinking a little bit further, we therefore should be able to take any global node, such as this one on the left, and represent it using the JavaScript object dot notation as shown on the right. And that's the underlying concept behind an open source node.js module that I created, which is named globals.js. Here's the GitHub repository. You can actually install and use it as a standalone module for Node.js. To do so, just use npm install globals.js. However, if you're using EWD.js, which is what it was primarily designed for, you'll find that it's automatically installed for you as part of the EWD.js installation process. EWD.js has a built-in dependency for globals.js defined in its package.json file. The projection or abstraction provided by globals.js is engineered using the basic cache.node APIs that I described in the previous section. So it automatically works with both the cache.node and node.m interface modules. In other words, what I'm describing in this section of the course will work and behave identically whether you're using cache, globalsdb, or GTM. So your normal use of this abstraction of global storage will be within your backend EWD.js modules. EWD.js automatically loads the globals.js module whenever a child process is started, and you'll access it using an object named ewd.mumps. However, it's useful to be able to use it in standalone scripts for testing or when debugging your backend EWD.js application logic, for example. When you do so, it's also useful to be dealing with the globals.js projection identically to how you would use it within your EWD.js application logic. So let me show you how to do that. Let's go over to my WinSCP connection that I've been using throughout this course. And let's take a look at this script file, globalsdemo1.js. You can use this as the basis of a test harness for your debugging and testing. This version is designed to work with cache, but as I explained in an earlier part of the course, you can easily change it to work with GTM by changing the commands at the top to load and initialize node.m instead of cache.node, and open a connection to GTM instead of cache. You'll see this first line requires the globals.js module. It's making use of the version that was installed along with EWD.js, hence the long path. Down here, these two commands are what you need to create the same runtime environment as you'd have within EWD.js itself, so always make sure you add these lines. From this point onwards, you can begin to use the globals.js abstraction. Here I'm just going to confirm it all loaded correctly by invoking this version function. This is just an abstracted copy of the same cache.node version function that we saw in the previous section of the course. So anyway, let's try this out in a putty session. So there's the cache.node and cache version details being displayed, confirming that our test harness script correctly loaded and set everything up. So now that we have that test harness pattern established, we can begin to explore the globals.js abstraction in more detail and see just what it does for us. The key part of the abstraction is this global node constructor. It takes two arguments, a name defining the name of the global, and subscripts, which is an array defining the subscripts for the specific global node that we're wanting to refer to. Of course, this should be familiar to you from the last section of the course. It's how the cache.node APIs themselves referred to a global node. So what does instantiating a global node object do for us? Well, it creates an instance of an object that represents a specific global node. And critically, the global node it represents may or may not yet physically exist in global storage. In other words, and this is essential to understand, instantiating a global node object does not create the global node. Instead, what it does is to provide you with an object that provides you with a set of properties and methods for accessing and manipulating the specified global node. So in this example here, we're instantiating a global node object that represents this physical global node and provides us with a set of properties and methods with which we can do things with that global node. So what kind of things can we do with the global node? Well, for a start, you can perform all the primitive actions. So we can create the node by setting a value, and you do that by simply assigning a value to its property named value. You'll notice that the value property name is actually prefixed by an underscore character, and you'll see that that's true of all the properties and methods of a global node object. Note also that if the global node had already existed, this would change its value. To get or retrieve the value of a global node object, we can just use the value property like this. So you can see that the value property is actually a read-write property. I hope you'd agree that this greatly simplifies the syntax and makes it much more intuitive than the explicit cache.node's get and set functions. To delete the global node, you invoke its delete method. Of course, if you do so, any subnodes below this global node will also be deleted as a result, just as we already explained in an earlier lecture in this course. And finally, there's another useful property, exists, that allows you to confirm whether or not a global node actually exists, either as an intermediate or a leaf node. Speaking of which, it can often also be useful to be able to determine whether a global node is an intermediate or leaf node. And you can use these further properties, has properties and has value, to discover this. So let's take this example here. We're instantiating a global node that represents the D subscript of this global, which you can see actually represents this intermediate node within the blue rectangle. And below you can see the values of the node's properties, has value, and exists. It's an intermediate node, so it does have lower level properties, or subscripts in MUMPS terminology. And because it's an intermediate node, it doesn't have a value, but it does exist. The same is true if the global node represents the node with subscripts D and E2, which can be visualized as the part of the global within this blue rectangle. But this global node object represents the leaf node shown in blue, so this time it not only exists, but it has a value, but it doesn't have any lower level properties. Now, if we instantiate this global node object, you can see from the representation of what the global contains that the specified global node doesn't actually exist. So as you'd probably expect, its exists property is false, as are also the has properties and has value properties. So that's the basic primitive properties and methods of a global node object. Let's see them in practice on my Linux Cache 2015.2 system. Of course, as before, the example scripts I'll be showing will all work identically on any cache, globalsdb, or GTM system. So let's switch to my WinSCP view of the Linux system. And we'll first look at this script file, globalsdemo1a.js. You'll see that this script refers to a global we've not used before, so it shouldn't exist yet in my cache database. So I'm instantiating this global node object and first testing for its existence. Then I give it a value and test it again. Then I delete it and test it again. It's probably pretty obvious to you what it will show when we run this script, but let's give it a go anyway. And just as you expect, it first shows it as not existing, then it does exist and you see its value, and then it's deleted and it no longer exists. Note that if you try and get the value of a non-existent node, it actually returns an empty string. So now, let's go back to working with the global that we've been using in all the previous examples that I've used in this course. That's myGlobal. If you've been trying out these examples yourself, you should probably still have myGlobal defined. But if not, you can recreate it by running this script file named ifdemo5a.js. So now let's have a look at this script file, globalsdemo1b.js. This is going to instantiate a global node object representing the D subscript in myGlobal. It will then show us the values of these properties. So let's run it. And as we'd expect for this intermediate node, it exists, has lower level properties, but doesn't have a value. Now let's have a look at this script file, globalsdemo1c. This does the same thing for the DE2 node, which is an intermediate node, and then does the same for the DE2F3 node, which is a leaf node, and the DE2F4 node, which doesn't actually exist in myGlobal. Again, you can probably guess what the results will look like, but let's check anyway. So here's the results from the intermediate node, then from the leaf node, and then from a non-existent node. So that pretty much covers the concept behind and the basics of global node objects. In the next lecture, we'll begin to see how much more powerful a way to represent global nodes this approach gives us, when we look in more depth at how a global's subscripts are abstracted as JavaScript object properties.